This is section 2.4, set operations and Venn diagrams with 3 sets. Most of what we're doing here is just an extension of what we did in the last section. We're going to be dealing with 3 sets instead of 2, so our Venn diagrams are going to have 3 circles instead of just 2, but the basic ideas are the same. We do have a couple of new properties here. The first one is the complement of A complement, so a double complement here is just the same as the original set. You can think of this as like a double negative where 2 negatives make a positive, 2 complements go back to the original. They undo each other. And then we have what we call De Morgan's laws. And this is all about what happens when you take the complement of an intersection of 2 sets or the complement of a union of 2 sets. And the way this works is very similar, and you can think of these together actually because the pattern is the same. You take the complement and you put it on each piece on the inside. So here we have A complement and B complement on both of those. And then the sign in the middle flips around. So this was an intersection, it becomes a union. This was a union, it becomes an intersection. So as long as we can remember that, we're going to be good. So let's look at just a couple of problems here. We dealt with problems like this with 2 sets. Now we're going for 3. We are given these sets, the universe, set A, B, and C, and we're asked to find each of these in roster form. So just list out what's in there. Now, parentheses go first, just like they do in arithmetic. So the first thing I want to find is B union C. So if I look at B union C, that's picking up everything that was in either B or C or both. So that would be the set 1, 2, 3, 4, 5, and 6. Now, if we want to intersect A with this set, then we're looking for what A and this set have in common. Intersection is what they have in common. So this answer, the one we're looking for, there is a 1 in common, a 3, a 5, and that's going to be it. So the answer they would be looking for is the set 1, 3, 5. For this one, the pieces, there are a couple more pieces we need here. I need to find C complement, I need to find B complement. So let's just do that. C complement. That means it's everything that is in the universe but is not in C. So we want everything that's not in C, essentially. So that would be a 1, 2, 3, 4, 5, 6, and then 7. So C complement is 1, 7. I need B complement, and we figure that out the same way. This is 1, 2, 3, so the complement is 4, 5, 6, 7. Okay. Now we need A union B complement. That means we pick up everything that is in A and everything that is in B complement, and we just put them together. So that's going to be 1, 3, 4, 5, 6, and 7. Now for the very last bit, so we finally get our answer right here, we are going to take C complement, which is here, and intersect that with this set right here. So what do these have in common? Well, our overall answer here, there's a 1 in common and there's a 7 in common. So the set 1, 7 is your final answer there. Okay, now for this last one, we've already figured out C complement and B complement, so we can just use what we figured out earlier and do each piece here. So C complement intersected with A. So C complement intersected with A. So what do they have in common? Just a 1 and a 7. So right here, That is the set 1, 7. Okay. Now C complement intersected with B complement. So here's where they are, and we're looking for the intersection. So what do they have in common? Only the 7. Okay, and then when we union these two sets together, that means we pick up everything that appears in either one of them. This overall answer will be the set 1, 7. Okay, so let's go on here. Using this particular Venn diagram, we're supposed to represent each set in roster form. So here we have the elements 1, 2, 3, 4, and so on in here. We have 13 here in the universe, and we're just asked to list whatever is in this region we're talking about. Okay? Now let's look at this. A union B, and then take the complement. The easiest way to do this is say, okay, well, what part is A union B? That's inside this circle and inside this circle. So everything inside those two circles, that's A union B. The complement means we want everything that is not in those two circles. Well, the only two numbers that are not in either of these two circles are 12 and 13. So this is actually the answer we're looking for, is 12, 13. Okay. Now let's do B union C complement. This is very similar. We're just using B and C this time, not A. B union C would be everything that's in these two circles. And then if we're going to take the complement of that, it's basically asking for everything that is not in either of these two circles. So that's going to be 1, 2, 3, and then the 7 I didn't cover up, and 13. Okay, now for A intersected with B intersected with C. There's no parentheses here, and that's technically because it doesn't matter what part you intersect first. Basically, this is saying, okay, what do all three of these sets have in common? And the only number they all have in common would be in this region right here in the center. So this answer is the set that contains 6. Remember that sets must be in braces except for the empty set. So your answer is not just 6. You shouldn't say that. I believe the computer will count it wrong, and several of your other higher level math teachers will definitely count it wrong. So just to be technically correct, they do need to be there. Okay, now the last one here. A union B union C complement. So again, there's no parentheses inside here because just like here where they're all intersection, when they're all union, the parentheses don't really matter. This just is saying we're going to pick up everything that's in A or B or C or in any of them or any combination of them. So without the complement part, A union B union C is going to be everything that appears in at least one of these 3 circles. So the only thing that is not, which is the complement, is 13.